We're going to begin Chapter 2, and in Chapter 2 we are covering frequency distributions and some graphs. I want to mention to my online students that your WebAssign quiz for 2.1 is worth significantly more points than the regular homework. So be sure that you have a good understanding of this, because if you do poorly on that particular assignment, it can hurt you. So what we're going to talk about first is the frequency table. And what this is it is a table that distributes our data into classes, which are also called intervals, of equal width. And each data value will fall into only one class. So what we're going to look at is the steps that you will follow when creating a frequency table. And if you'll notice on this page of notes, I have all the steps, and then there is an example at the bottom of this page, and then it will go into the next page of notes in which we will follow all of these steps. So let's get started. Step 1, determine the number of classes to be used. 5 to 15 is the most common. Make note that this will already be determined for you in each problem. So if you'll look down here at the example, it says a professor in the math department kept a list of the number of students visiting her office for 2 semesters, which equals 30 weeks. The following are the results. So this number right here represents 1 week in which 15 students came by the office. This would be a second week, and then this week 16 students came by. And so we have 30 data values. But if you'll notice down here, it says use 5 classes. Well, this is what's talking about. This is our step 1. You'll never have to determine that. That will always be determined for you. All right, coming back up here. Step 2 is to calculate what is called the class width. And when we create a frequency table, those intervals have a particular width, and this is determined right here in the class width. Now, how we calculate the class width is we look for the largest data value minus the smallest data value, and then we divide by the number of classes. And of course, these numbers will change with every problem. So I'm going to come down here and I'm going to locate the largest and the smallest, and we already know our number of classes for this particular example is 5. Be very careful in this step, because if you calculate an incorrect class width, then it messes up your whole table. So to be honest with you, when I was going over this problem, I was skimming my numbers and I located the number 28, and I was like, okay, that's my largest, and I located the 3. Then what I did is I went back through just kind of quickly to make sure there wasn't a number bigger than 28 or smaller than 3, and lo and behold, I found 32. So had I used 28 as my largest number, the whole thing would have been messed up. So my largest number is 32, my smallest number is 3. Now I'm going to switch over to the next page of notes, because that's where I have class width written. So to calculate the class width, we will take 32 minus 3, and we will divide that by 5. Now be careful when you're calculating this in your calculator. Be sure that you either put the numerator in parentheses, or you enter 32 minus 3 equals divided by 5. Otherwise, if you just put in 32 minus 3 divided by 5, the calculator will only divide the 3 by 5. So be very careful of that and don't make a calculator error. So this would be 29 divided by 5, and when I go to my calculator, I get 5.8. Now, this particular example, we had a terminating decimal. Sometimes it will repeat, sometimes it'll just go on forever and never stop. So it doesn't matter, but the same rule applies. I'm going to come back here to where there's additional information on class width. This throws some students. We do not use normal rounding rules. We always round up. Now for this particular example, since this would fall into normal rounding rules, my class width is 6, and that would be correct. But when it says always round up, if I had another example and we had calculated 5.12, students want to say the class width is 5 because that would follow normal rounding rules, but we do not follow normal rounding rules. So had we calculated 5.12, the class width would have also been 6. So it's one of the few times in this course that we don't use normal rounding rules, but just make sure that you pay close attention to that because that will mess you up if you do that incorrectly. All right, step 3. Now if you'll notice on this next page of notes, I have a table already created. This 3 means this column is step 3. So this is what we call our class limits. This is very important. Make sure to establish all lower class limits first, and I'm going to show you how to do that. It says start with the smallest value. So our smallest value for this particular example was 3. If we were doing another problem, the smallest value could be 65. It would just depend on the set of data. But for our example, it is a 3. To find the next lower class limit, add the previous lower limit to the class width. So what this is saying is to find the next lower class limit, we're going to add our class width that we just calculated, which was 6. So what we'll do is establish all our lower class limits, and we will add the class width, which in this example is 6. So I would do 3 plus 6, which would give me a lower class limit of 9, plus 6 would be 15, plus 6 is 21, and plus 6 is 27. Now what we're going to do is we are going to establish our upper class limits. And how we do this is my upper class limit is just 1 less than this lower class. So 9 minus 1 is 8. So this would be 8. 15 minus 1 is 14. 21 minus 1 is 20. 27 minus 1 is 26. Now if you'll notice a consistency here in my upper class limits, 8 plus 6 is 14, plus 6 is 20, plus 6 is 26, which helps me then do plus 6, which is 32. Now one thing I want to mention here, in our particular example, this last upper class limit is our largest data value. That will not always be the case. It does not have to be this last one. If our smallest number was, if our largest number was 31, but this number when I added 6 was a 32, you just leave this a 32. Because what we have now is in each class, or in each value, there are 6 numbers represented. And the class width is 6, so 3, 4, 5, 6, 7, 8. 6 numbers are represented. 9, 10, 11, 12, 13, 14. 6 numbers are represented. And that is an important characteristic that needs to hold true. All right, going on to step 4, which is our class boundaries. And our class boundaries says subtract 0.5 from the lower class limit and add 0.5 to the upper class limit. So this would be 2.5 to 8.5, 8.5 to 14.5, 14.5 to 20.5, 20.5 to 26.5, 26.5 to 32.5. And that's all the class boundaries are. And the purpose for the class boundaries you'll understand when we start creating graphs based upon the frequency table. All right, the next step is our midpoints, and this is the midpoint of each class. So you take your lower class limit, add the upper class limit, and then we always divide by 2. So 8 plus 3, that's 11, divided by 2 is 5.5. So the midpoint of this limit is 5.5. So then we would do 9 plus 14 divided by 2, which calculates to 11.5. 15 plus 20 divided by 2 is 17.5. And of course, we can continue doing this, or what I would like to point out, if you're confident you have calculated even the first one correctly, if you will notice the difference between each one is the class width of 6. So 5.5 plus 6 is 11.5, plus 6 is 17.5. So we can just add 6, and this is 23.5. Add 6, and we would get 29.5. Of course, you can do 21 plus 26 divided by 2. You'll get the same calculations, and 27 plus 32 divided by 2 would be 29.5. Whichever way you choose is fine. All right, step 6, frequencies. It's the number of data values that fall into that class. All right, so here's what we're going to do. I'm going to get the original data values. Let me fold something on this page so maybe I can get it all in there a little bit better. Okay, so what we're going to do is create tally marks. So 15 falls between 15 and 20, so I'm going to make a tally mark. 16 is also in that class, as well as 20. Then we have 23, which would be in the next class, 32, 12, 17, 27, 8 is in the first class because 8 falls in between 3 and 8. 13 would be between 9 and 14. 4, 10, 3, 20, and since I have 4 here, I'm going to go ahead and do this so I can do tally marks in groupings of 5. 25, 9, 3, 10, 7, 28, 8, 6, 5, 15, about put it in the wrong one, 8, 6, then I have 3 11s, so 1, 2, 3 11s, and then a 9. All right, so I'm going to make sure I got the same thing I got earlier when I worked this problem. So I have 10 numbers that fall there, 9, 6, 2, and 3. Now, a good thing to do here is to total these up, because if we go back to the original problem, it said we had 30 weeks, so we should have 30 data values. So there's 19, 25, 26, 27, 28, 29, 30. So this does add up to 30, so I know I have used all the data values and I have not skipped over one. Okay, then step 7 is our relative frequencies, which is this will be calculated by taking, sorry about the phone ringing. I got it fixed, thanks. That's okay. I'm recording right now, so I'm going to let you go. Okay, bye. Sorry about that. We'd had some technical difficulties, so just disregard that phone conversation. Okay, so to calculate step 7, we're going to do the frequency of each class divided by the total number of data values. So the frequency would be 10, divided by the total number of data values is 30, and then we would have 9 divided by 30, 6 divided by 30, 2 divided by 30, and then 3 divided by 30. And then what I'm going to do is convert these to decimals. Now at this point, if you round to 2 decimal places, that's fine. If you're on WebAssign, be careful. they will specify. Sometimes they'll say round to 2 decimal places, sometimes they will say 3. And so if it says round to 3 decimal places and you only go to 2 decimal places, it's going to count it incorrect. But for purposes of my notes, I'm going to only go 2 decimal places and use normal rounding rules. So this one comes, whoops, I already did that. I'm doing squiggly because it's not exact. I'm going to round to 0.33. The next one is a terminating decimal, 0.3, and then I have 0.2. And if I remember correctly, this is 0.06666, so I'm going to round to 0.07. And then the last one is 0.1. Now, here's another good checkpoint. We have converted these into decimals, and what this means is 33% of the data falls within this first class. 30% of the data falls in class 2, 20%, 7%, and 10%. So if I am including all of my data values, then this column should add up to 1, which it does. But beware, in other examples, it may not come out to exactly 1 because you are rounding. It might be like 0.99 or 1.01, just depending on how the rounding goes. So if that were to happen, it's okay. It doesn't have to always be exactly 1. All right, step 8, cumulative frequencies. Whoops, you can't see it. Okay, here we go. It's the number of data values in that class and the previous classes. This is a running total. So here's how we would do that. The first class is just that number because we don't have anything previous. So then I'm going to take this 10 and add the number in the next class, which is 9. So 10 plus 9 gives me my 19, plus 6. We now have a running total of 25, plus 2 is 27, and plus 3 is your 30. And another checkpoint right here is make sure that this last value is your total number of data values. So this is a running total. It's saying we have a total of 30 values, which we do, so we know we're okay. Now, one other thing I want to mention before we get into the graphs, one of the things we'll be doing on the graphs is labeling our graphs, and students struggle with that a little bit. So I have found that if I do some labeling in my frequency table, then we are less likely to mess up when we go to our graphs. So let's go back to what these numbers represent. All right, so we know a professor in the math department kept a list of the number of students visiting her office for 2 weeks. So it's or 2 semesters, which is 30 weeks. The following are the results. Now, here's why I wanted to mention that. Your class limits, this 3 to 8 is talking about there being 3 to 8 students that would visit the professor. So your limits and your boundaries is talking about the number of students. 9 to 14 students, 15 to 20 students, and so forth. And it goes on up to the 32 students that we talked about right here. So this class limits and class boundaries, any graphing I do, if I'm dealing with these numbers, I will label that axis as students or number of students. So then what I'm going to go over to is frequency and relative frequency. What does this 10 mean? The most common error is students would say this represents 10 students, but that is incorrect. This means that there were 10 weeks that 3 to 8 students came by the office. There were 9 weeks in which 9 to 14 students came by the office. There were 6 weeks and so forth. So this column, which would also be your relative frequency, this deals with the weeks or number of weeks. So that will be helpful when we go to create our graphs. So the first graph that we are going to create is what is called a histogram. There are some characteristics of a histogram you need to be aware of. This is a bar graph. Okay, so this is a bar graph. The bars have the same width and they always touch. So you've seen bar graphs that don't touch. They're still bar graphs, they're just not histograms. A histogram is a bar graph in which the bars always touch. The width, or how wide the bar is, represents a quantitative value, not a category. And the width of our bar goes back to your class width. So in our case, the width of our bar would be like 6 units on a number line. Place the class boundaries on the horizontal axis. All right, so I'm going to come down here and we're going to have a vertical axis, and we are also going to have a horizontal axis. And it says the class boundaries, which is your step 4, which is, it's your step 4, your class boundaries. This represents number of students. So I'm going to start with 2.5. And then 8.5. And I don't have graph paper, so I'm just going to visually make it like 6 units apart. It might not be exact if we got a ruler out, but if you will make it visually appears that they are the same width, I am okay with that. And I'm going to go ahead and label this axis because I have to label my graph. I've already established that this is your class boundaries, which is your number of students. All right, then it says place the frequency on the vertical axis. So here's my vertical axis. Here's my frequency. The largest number is 10, so I'm going to go by 2s. And because I made sure that I established this when I was creating my frequency table, the frequency deals with the frequency of weeks that this occurred. So when I label this, it will be frequency of weeks. So what I'm going to do now, it says create the bars above each class. The height, or how tall it is the frequency of that class. Now, this is something right here. The book does not, what's the word I'm looking for? It does not necessarily say you have to do this. On WebAssign, it may not allow you to do this, and that's fine for my online students. But for my in-class students, I want you to always put the frequency number above each bar. So the first class was 10, so I am going to create a height of 10, and then I'm going to put that number above. Then the next one is 9. And then we have a 6. And then we have 2. And then we have 3. And then the last thing that we need to make sure that we do is give our graph, or in this case a histogram, we need to title the graph. So what I know about this is that it was student visits to math professor for 2 semesters. You just need to be sure that you include all the pertinent information that goes along with the graph. And one of the things, of course, we know it's number of students. We know we're dealing with number of weeks here. So we want to know that it's a math professor, and so just your title will not always be the same as maybe somebody else's, but just make sure that you include all the important information involved. Okay, now, bar graphs can take on particular shapes. This is covered in the book, so I want to give you an idea of these different distribution shapes and what they would look like. So, the first one is symmetrical. So let me give you a rough draft of what a symmetrical histogram might look like. Now, what it states is that if you were to fold this graph in half, it would look more or less the same on both sides. So if you'll notice, here's my tallest. These two are exactly the same. This next one is not the exact same height as the other, but more or less it is, as well as these two bars. So this is what a symmetrical histogram looks like. Then we have what is called uniform. It's also called rectangular. And it would look, whoops, I didn't do that very well. My bars aren't exactly the same width, but you get the idea. It's a rectangle, and that's why it can also be called rectangular. I tend to call it uniform. And what you'll notice is they all have the same height. So what that would tell me is for every class, they would have the exact same frequency, because frequency is what determines the height of your graph. Then we have what is called skewed left or skewed right. So skewed left might look something like this. And basically it means if you look at your tallest bar, it's heavier to the left side of having more bars. Sometimes it may be that's the only way that they have it. It would look like this. But you could have additional bars on the other side, but there are more bars on the left of your tallest. A skewed right then would just mean that it goes heavy to the right side. So an example of that might look like this. So that would be an example of skewed right. And then the last one is what is called bimodal. And an example of a bimodal histogram how to determine if it's bimodal is you locate your two tallest bars. If there is one or more bar in between them, it is considered bimodal. So these are the most typical distribution shapes. Now, they won't all fit exactly how we want them to, because if you'll look back here, let's take a look at our histogram. When I look at this and I start going through the different ones, I can go, well, I know it's not symmetrical. I know it is not uniform. It is not bimodal because here are my two tallest and there is not a bar in between them. So if I've eliminated all of the others, that means it has to be skewed left or skewed right. Now, what might make some students question that is because this bar then jumps back up, but it would still be most like a skewed right distribution shape. So sometimes if you don't look at it and you don't know immediately which one it is, use the elimination process and then choose the one that it is most like. All right. Then, let's see. Our next graph that we are going to do is the relative frequency histogram. So since we are creating another histogram, I know this is a bar graph. A relative frequency histogram is exactly like the histogram we just created, except the vertical axis is your relative frequency instead of your actual frequency. So I have my vertical and my horizontal, and our horizontal was the class boundaries, so I'm just going to redo that as we had done last time. Let's see, and then 26.5 and 32.5. And we had already established that this is the number of students. But now on the vertical axis, we had done frequencies. Now we're going to do relative frequencies. The largest number is 0.33. So I might go 0.05, 0.10, 0.15, 0.20, 0.25, 0.30. And this is relative frequency of your weeks. And the first bar, oops, I'll pull that down. Sorry about that. The first bar was 0.33, so I'll go a little above that. And then we have 0.3. Now please be careful. Here we have 0.3. I have students that will create that and put it down here and say this is 0.3. What they have graphed is 0.03. 0.3 is the same thing as 0.30. So be sure you don't make those errors when you're creating your graphs. Then we have 0.2, which is 0.20. And then we had 0.07. And then 0.1, which is 0.10. And if you'll notice, it looks just like, see if I can find it, the other histogram, which it should. Let me see if I can get both of those in there. Because these 10 patients make up 33% of the data. These 9 patients make up 30% of the data. So these 6 people are these same 20% of the data. So it makes sense that they look the same. Now, what we don't want to forget to do is title, and I'm just going to leave the same title. Student visits to math professor for 2 semesters. And there we go. That's your relative frequency histogram. Now what we're going to create is what is called an ogive. Now an ogive is a, whoops, I'm getting ahead of myself. All right, the ogive, oh that's right, is a line graph. Sorry. Okay, so the ogive is a line graph instead of a bar graph. So let's look at what it tells us to do. Again, we're going to put the class boundaries on the horizontal axis. So I'm going to have a vertical and a horizontal, and I'm going to do the class boundaries. So 2.5, 8.5, 14.5, 20.5, 26.5, and 32.5, and I know this is number of students. Place the cumulative frequency on the vertical axis. So here's my cumulative frequency, which starts with 10, goes up to 30. So I need this to go up to 30, so I might go by 5s. So 5, 10, 15, 20, 25, 30, and this is cumulative frequency of weeks. Mark a dot on the horizontal axis at the first lower class boundary, so that would be right here. Mark a dot at the cumulative frequency on each upper class boundary. So that would just basically be these next 5. So now I'm going to find 10, which would be here. I'm going to put the number above it, and then we have 19. And then we have 25, 27, and then we have 30. And now I'm going to connect my dots. And of course, I need to then put my title. Student visits to math professor for 2 semesters. A couple things I want to point out. One is the cumulative frequency, or the ogive, will always go upward. It will never dip back down and then go back up. Now, what it could do is it could go 10, 19, 19, 27, and what that would just mean is there is a class that does not have any frequency in it whatsoever. But it will either stay the same or go up. It will never ever dip back down. This last number should be your total number of data values. Now, the purpose of the ogive is to know, like, you might be asked, how many students are below let's see, I'll go 20.5. Actually, that would be how many weeks? Sorry about that. How many weeks are below 20.5 students? So 20.5, this would tell me that there are 25 weeks in which there were 20 or fewer students that went by the office. Sometimes it also might ask is what percentage was below that. So all you would do is you would take the 25 and then divide it by the total, which is your 30. So we take 25 divided by 30, we get 0.83 repeating. Is that right? Yeah. So it's 83.3%. And that's the purpose of an ogive, so they can see how many are below a particular number. All right. The last graph that we are going to create is called a frequency polygon. Now, please be aware, I need to double check this edition. In my previous editions, if I go way back, the frequency polygon is in the book. In my last edition, it was not. To be honest, I have not double checked in the 12th edition, and I should, and I will do that after I finish this lecture. But This may not be covered in the book, so be sure that you can create this. My online students, if it's not in the book, WebAssign won't ask you a question on this. But I'm also creating this for my in-class students. If they want to watch this lecture, they are responsible for a frequency polygon. All right, so one thing we have to do with the frequency polygon is we have to find what is called the starting point and the ending point. So the starting point is your first midpoint. So what this is a line graph of your midpoints. Let me go back here to my midpoints, and here is my first one, 5.5. So my first midpoint, 5.5, minus the class width, and the class width is 6 for this particular example. Well, notice when you take 5.5 minus 6, you get negative 0.5. And you're going, should I get a negative? Well, we calculated it correctly, so yes, getting a negative is fine. To find the ending point, we're going to take our last midpoint. So if I go to my table, my midpoint, my last one is 29.5. Now I'm going to add the class width. So that would give me 35.5. So this is my starting point, and this is my ending point. Now where that will go is on your horizontal axis, because if you'll notice the next bullet, it says place the midpoints on the horizontal axis, but be sure you include the starting and ending point. So I want to show you something on the horizontal. Now, I left a gap here, and here's why. Typically, we think of this corner as being 1 and then a number line going to the right, but I go, I'm starting with a negative number, which is kind of odd. So we're going to use this little squiggly line, which is called a changing scale. And the reason that is just to bring people's eye and attention to this. So we wouldn't normally start with a negative number, but since we are, I'm going to use that changing scale to let people know that, hey, it's kind of an odd value to start with. And then I'm going to use my midpoints. So 5.5, 11.5, 17.5, 23.5, 29.5, and then I need my ending point, which is 35.5. Now, these midpoints were calculated off of the class limits, and the class limits are your number of students, so will our midpoints be. So the starting point, you put a dot, and the ending point, and then place frequency on the vertical axis. So not relative frequency, I'm going to go back to frequency, which is 10. So I'm going to go by 2s. And that is frequency of weeks. So we're going to mark a dot over each midpoint. So we would have 10, and then we have 9, and then we have 6, 2, and then 3, and then we connect our dots. And then we put our title. Student visits to math professor for 2 semesters. If somebody put for 30 weeks there, I would be fine with that, just so I have all the information. That covers all of 2.1.